One algorithm wins more Kaggle competitions than almost anything else.
It's not the fanciest. It's not the newest. But it works.
You already know boosting from last episode, models trained in sequence. Gradient boosting takes that one step further.
Every new tree fits the residuals, the exact errors the last tree made. Add regularisation, column subsampling, and parallel speed on top.
That's XGBoost. Decision tree, 73%. XGBoost, 83%.
This is episode 14, Gradient Boosting and XGBoost Explained. Quick recap from last episode. Boosting builds models in sequence.
Each new model focuses on what the previous one got wrong.
Misclassified examples get upweighted, the next tree pays more attention.
Each individual tree is weak, the sequence together is strong.
Here's the gradient part where the name actually comes from. You have a loss function, a measure of how wrong your predictions are. Gradient descent finds the minimum of that loss by following its slope downward.
Each new tree is one step in that descent, fitting the negative gradient.
This gradient descent, but with trees instead of weight updates.
Vanilla gradient boosting works. XGBoost makes it competition grade.
L1 and L2 regularisation. Complexity is penalized, harder to overfit. Row subsampling and column subsampling. Decor relates the trees, like random forest.
Parallel tree construction internally, much faster than original GBM.
Native missing value handling and pruning by gain threshold. XGBoost has a lot of hyperparameters. Most of them you won't touch. Learning rate. How big each tree step down the gradient is.
N_estimators, how many steps total. Lower rate needs more estimators.
Max_depth. 3 to 6 is almost always right. Deeper risks overfitting.
Subsample and callsample_by tree. Both around 0.8 is a good start.
XGBoost isn't the only gradient boosting implementation. LightGBM grows trees leaf-wise instead of level-wise, faster on large data.
CatBoost handles categorical features natively, no one-hot encoding needed.
All three share the same boosting core, the difference is engineering. Random forest and XGBoost look similar. They solve different problems. Random forest fights variance. Parallel trees, each calming noise.
XGBoost fights bias, sequential trees, each shrinking remaining error.
Random forest. Easier to tune, harder to overfit, trains faster.
XGBoost, more accurate on structured data, needs more careful tuning.
When should you reach for gradient boosting specifically?
Tabular, structured data, this is its natural home.
Kaggle competitions, industry pipelines, mixed feature types. Limited data where deep learning can't gain traction.
Anywhere you need feature importances or SHAP values built in.
In code, XGBoost is one import and then the same sklern pattern.
Pip installs boost, from xboost import XGB classifier.
Set learning rate, N_estimators, max_depth, subsample. .fit, .predict, same as everything else in this series. Real demo. Same noisy dataset as episode 13, same train test split. Decision tree, max depth 5, 73.3%. Random forest, 200 trees, 79.6%. XGBoost, 300 estimators, learning rate 0.05.
83.1%, nearly 10 points ahead of the tree.
Gradient descent on residuals really does compound the gains. XGBoost also tells you which features drove the predictions.
Feature_importances_ is available immediately after fit, no extra steps.
It ranks features by total gain contributed across all trees. This is the same output we'll use in the feature selection episode. Let's lock in what we covered.
Gradient boosting, trees in sequence, each fitting the previous one's residuals.
XGBoost, gradient boosting plus regularisation, subsampling and speed. Versus random forest, boosting fights bias, bagging fights variance.
Feature importances come for free. Key params, rate, depth, subsample. If that jump from 73 to 83 clicked for you, subscribe.
Quick look at where we are. ensemble learning, then gradient boosting. Now those two are done.
Episode 15 goes to hyperparameter tuning, grid search, random search, Optuna.
You just trained XGBoost with defaults. Next episode, you'll tune it. Episode 15, hyperparameter tuning explained.
Grid search CV, randomized search CV, and Bayesian tuning with Optuna.
We'll tune the same XGBoost model from this episode. Subscribe.
Your challenge task for this episode.
Train a decision tree baseline, then a random forest, then XGBoost. Compare test accuracy and wall clock training time for all three.
Bonus. Plot the XGBoost feature importances as a bar chart.
Post your 3 accuracy numbers in the comments.
Did XGBoost beat your random forest? By how much?
Full solution is in the repo. Try it before you peak. A decision tree, 73%.
XGBoost correcting its own mistakes, round by round, 83%.
Episode 15, hyperparameter tuning explained, drops next. Subscribe. Comment with your XGBoost versus random forest numbers.
I'm Majas. This is CodeToAGI. Let's build.